Slow feedback loops can be very pleasant. You handed your work in, and now you can just sit back. If you are a student, then the teacher will grade it. If you are an employee, then your colleagues or boss will review it. If you are a software developer, then you have to wait for the code to compile or be reviewed. You just sit back and wait. No more stress about getting the work done. Sounds great, doesn't it? Here I want to argue that slow feedback loops can waste a lot of time. I think the main problem is that to learn, we have to receive information. For example, a theory is based on pieces of evidence. To learn that apples fall down when dropped, we first do many experiments. We throw it in the air and see that it falls down. Then we drop it when we are in the garden and see that it falls down again. After doing all the experiments and find that the apple falls down every time, we can conclude that an apple falls down when dropped. But learning can be on a smaller scale too. For instance, a child can learn that a door opens when you push it. The child learns that if the door is not pushed, it doesn't open, and if the door is pushed, it opens. The child can then use this knowledge to open the door. But now imagine that the child does not immediately receive the information that the door opens when pushed. Say that pushing a door has to happen through a computer and it takes a year to get the result. The child can then still learn that the door opens when pushed, but assuming nobody else tells them, it will take at least a year to learn that. So the way to think about this is to think about how much pieces of useful information you can receive. If you're writing software or doing work in the real world, then you can receive pieces of information very quickly. If you burn your hand on a stove, your body will process the information in less than a second. If you are a mathematician, you can see whether the math works almost instantly. But in some scientific fields, the feedback loop is much slower. When you submit your paper to a journal, it can take multiple months before you get the first review. Imagine you are an honest researcher that wants to learn something new. You take a year to do multiple experiments and collect data, then you write a paper and submit it to a journal. There are multiple co-authors and 2 peer reviewers who will review your paper and may give feedback. Then the paper is published, and now some people could start to cite it or criticize it, but the critique also takes months to years before it is published. Overall, it may take 2 years before you get feedback on your work. This is probably why academic conferences are important. When presenting your work on a conference, you can get feedback on the same day. However, overall, the feedback loop is still too slow. I think this plays a role in why most published research findings are false. There is a related story about pottery in the book Art and Fear by David Bales and Ted Orland. In the book, a ceramics teacher divided the class into 2 groups. One group was told, make as many pots as possible. Another group was told to make the highest quality pot possible. In the end, the highest quality pots were made by the group that was told to make the most pots. As the author wrote, the quality group had sat theorizing about perfection, and in the end had little more to show for their efforts than grandiose theories and a pile of dead clay. Another situation where slow feedback loops are a problem is for investors. Warren Buffett is likely one of the best investors of all time. His company, Berkshire Hathaway, did not invent a medicine to cure cancer. They didn't build rockets or a new cool app. No, they just invested in companies and waited for the price to go up. This is based on the idea of value investing, that a company has a certain value and that the price at some point will go to that value. The trick is to find companies that are selling at a price below their value. However, it can take years for the price to go up to the true value. This is because it takes time for a company to grow. Even the best companies will not grow at hundreds of % per year. Instead, a company is already considered great if it grows at 30% per year. This is a stark contrast to things on a smaller scale. If I have $10 in my bank account, I can easily add 30% to it in one day, and 30% again the next day. Or if I'm writing a blog post, I can write 30% of the text in 1 hour and post it to 30% more people in the next hour. So how does Buffett handle it? I think he does it by thinking. He said it himself that he mostly spends his time reading biographies and thinking. His feedback loop is in his head. He runs the feedback loop there. But still, he is also the first to admit that he is often wrong. In 58 years of Berkshire management, most of my capital allocation decisions have been no better than so-so. So here we have one of the best investors of all time. And still, he makes many mistakes. I think that's just another example of how slow feedback loops can be a problem. You can be one of the smartest people in the world, but if your feedback loop is slow, then progress will be too. This is why it's important to spot slow feedback loops and speed them up when possible. Try to avoid analysis paralysis, push results out and find feedback. If you are a programmer, run the code on your own computer instead of on a server. If you run a company, find customers and talk to them directly instead of asking your colleagues. If you are in government, run small pilot programs instead of multi-year studies. And yes, these things are easier said than done. But in the end, you might find that it's worth it to keep moving.